Hello everyone, I hope you all are doing good. So in today's data structure tutorial, I'm going to discuss on topological sort, which is a linear ordering of vertices such that for every directed edge, U to V, vertex U should come before vertex V. Okay. Mainly we use topological sorting for scheduling the job, scheduling the jobs from the given list of dependencies. Okay, so in my computer science application, if I have a parent job which is having multiple children job as well, so for scheduling those job in a particular order, I make use of topological sort. Let me explain it with an example. I have this graph and I can see that this is a directed graph. So how we are going to perform the topological sort for this one? I can see that there is no edge that precedes A, so I can start from A. Similarly, there is no vertex uh, that precedes F, right? There is no edge from any vertex to F. So I can take F as well. Then it will be B from A to B, then B to D, D to E. And finally, we have covered all the vertices except C. Fine. Um, One point to note is a graph can have more than one topological sort. So if I had to generate another topological sort for this graph, it will be F to A, then we have B, D, and E, and C, right? We can, in this sort, after A, I have put F, right? But we don't have any edge. So, and even the in degree for A and F is 0, right? And one more thing we can notice is the last vertex C is having only the in degrees. There is no out degree. Okay, so the last vertex is C here. Let's implement this in C++. I'm going to use the same graph that we have been using since we started the graph tutorial. And let's check what is the topological sort for this graph. Okay, so we have been using this graph implementation in C++, right? V for vertex and the adjacent list, which denotes the adjacent vertices for the every vertex in the graph. So now let's define the function for topological sort. Okay, so let's declare it. Return type, class name, function name. Okay, so the first step is I'm going to use the data structure stacks here, so that I'll define where we are using it later in the video of type int. Okay, then to keep the track of the visited nodes, I'm going to take an array of Boolean type, and size would be number of vertices in the graph. Going to use the for loop and initialize all the visited node as false initially. So visit I as false. Fine. Now for every vertex, we are going to check if it is not visited, then perform the topological sort. So for int I I less than v, I plus plus, sorry, what I'm going to check, if not visit I, then I'm going to say, I'm going to call a function which I'll be defining now, where I'm going to pass that vertex and the status of that vertex. So visit and my stat. Okay, so let's define that function. Void. So what all parameters? Three parameters. The first one would be vertex, so I'm taking it as root. Then the array for the visited, so bool visited, and then stat, type of int. Fine, semicolon. Now let's define this function. Void my graph, function name, parameters, root visited, and the stat. Fine. Okay. The first step is whenever a particular vertex is entering this function, we should put visited as true. So visited root is true. Then I'm going to put an iterator to traverse all the adjacent list for that vertex. So here I'm starting from 0. I need to have an iterator to check for the adjacent list, that is 1 and 2. So let's define the iterator of type int. Iterator, sorry, t. I'm going to use for loop adjacent for the that particular vertex, that is root dot begin till the end. So it not equal to dot end. Fine. Then it plus plus. So here what I'm going to check, if not visited, value stored at it, then I'm going to do the recursive call to topo itself. So value stored at it, comma visited, comma stat. Fine. So what I'm doing, 0 visited true, checking the first adjacent element, 1 true, then calling the topological sort again. I'm going to 2 and calling the topological sort again, right? If it is not visited. So then I'm putting it as visited and calling the topological sort for 3. Now when I'm reaching 3, what I'm going to do, I'm going to push it to the stack. So dot push root. So here I have pushed the vertex 3. Okay, so we are going from 1 to 2, 2 to 3, right? So from 3, then we are recursive in nature. So the next push is going for 2, then for 1, then for 0. So I'm using this tag data structure for the topological sort. So I have find the linear ordering. Now I am going to display it in my topo demo function. So here what I have to do is, while my stack is not empty, keep on publishing and popping the item. So if s dot empty is equal to false, printing, so cout s dot top, putting some space, and then pop the top element. Fine. Let's run this program. Oh, the key point, we forgot to call the function of topological sort itself. Cout topological sort, endl for the new line, and then I'm just going to call the function g dot topo demo. So now let's rerun the program. So the topological sort is 0, 1, 2, 3. And we can clearly see that 0 to 1. So vertex 0 precedes 1, right? 1 precedes 2, 2 precedes 3. I'm going to provide the GitHub link in the description section, and you can check for other graph structures as well. I hope you like this video. If you want me to touch on other topic related to graph traversal and other sorting, please put in the comment section. Thank you. Have a good time.